Relativity. Part 1. The Special Theory of Relativity. Chapter 1. Physical meaning of geometrical propositions. In your school days, most of you who read this book made acquaintance with the noble building of Euclid's geometry, and you remember, perhaps with more respect than love, the magnificent structure on the lofty staircase of which you were chased about for uncounted hours by conscientious teachers. By reason of your past experience, you would certainly regard everyone with disdain who should pronounce even the most out-of-the-way proposition of this science to be untrue. But perhaps this feeling of proud certainty would leave you immediately if someone were to ask you, "What then do you mean by the assertion that these propositions are true?" Let us proceed to give this question a little consideration. Geometry sets out from certain conceptions such as plane, point, and straight line, with which we are able to associate more or less definite ideas, and from certain simple propositions, axioms, which, in virtue of these ideas, we are inclined to accept as quote-unquote true. Then, on the basis of a logical process, the justification of which we feel ourselves compelled to admit, all remaining propositions are shown to follow from those axioms, i.e., they are proven. A proposition is then correct or true when it has been derived in the recognized manner from the axioms. The question of the quote-unquote truth of the individual geometrical propositions is thus reduced to one of the truth of the axioms. Now, it has long been known that the last question is not only unanswerable by the methods of geometry, but that it is in itself entirely without meaning. We cannot ask whether it is true that only one straight line goes through 2 points. We can only say that Euclidean geometry deals with things called straight lines, to each of which is ascribed the property of being uniquely determined by 2 points situated on it. The concept true does not tally with the assertions of pure geometry, because by the word true we are eventually in the habit of designating always the correspondence with a real object. Geometry, however, is not concerned with the relation of the ideas involved in it to objects of experience, but only with the logical connection of these ideas among themselves. It is not difficult to understand why, in spite of this, we feel constrained to call the propositions of geometry true. Geometrical ideas correspond to more or less exact objects in nature, and these last are undoubtedly the exclusive cause of the genesis of those ideas. Geometry ought to refrain from such a course in order to give to its structure the largest possible logical unity. The practice, for example, of seeing in a distance 2 marked positions on a practically rigid body is something which is lodged deeply in our habit of thought. We are accustomed further to regard 3 points as being situated on a straight line if their apparent positions can be made to coincide for observation with one eye under suitable choice of our place of observation. If, in pursuance of our habit of thought, we now supplement the propositions of Euclidean geometry by the single proposition that 2 points on a practically rigid body always correspond to the same distance or line interval, independently of any changes in position to which we may subject the body, the propositions of Euclidean geometry then resolve themselves into propositions on the possible relative position of practically rigid bodies. Note, it follows that a natural object is associated also with a straight line. 3 points A, B, and C on a rigid body thus lie in a straight line when the points A and C being given, B is chosen such that the sum of the distances AB and BC is as short as possible. This incomplete suggestion will suffice for our present purpose. End of note. Geometry, which has been supplemented in this way, is then to be treated as a branch of physics. We can now legitimately ask as to the truth of geometrical propositions interpreted in this way, since we are justified in asking whether these propositions are satisfied for those real things we have associated with the geometrical ideas. In less exact terms, we can express this by saying that by the truth of a geometrical proposition in this sense, we understand its validity for a construction with ruler and compasses. Of course, the conviction of the truth of geometrical propositions in this sense is founded exclusively on rather incomplete experience. For the present, we shall assume the truth of the geometrical propositions, then, at a later stage, in the general theory of relativity, we shall see that this truth is limited, and we shall consider the extent of its limitations.